Hi and welcome back. In the last video we looked at mutability and now we're going to look at passing arguments in Python. Let's look at a couple examples of arguments in Python, and I'm going to show you this dictionary here. Dictionaries are a great example of mutable data structures. And then we'll create a function called cFriend that is going to allow us to see a friend that we didn't see for a long time. So cFriend, friend's name. And this function, all it will do, it'll say friend's name equals 0. If we pass in friend's last seen and Rolf, it'll set Rolf's value to 0 instead of 31. Now, here comes the interesting bit. We're going to print out the ID of friends here. Inside the function, this is the parameter friends. Then, we're also going to print the ID of friends last seen, which is our dictionary that is in the global scope. Finally, we are going to call cFriend with friends last seen and Rolf, and we're going to print the ID of friends last seen. How many different numbers do you think we are going to see here? Hopefully the answer was one number only, but we'll see. Notice how the first thing we printed out was this friends last seen here, and it's a number. Then we called cFriends and we passed in friends last seen. The name changed over to friends, but actually the number is still the same. It's still the same dictionary, this one here. Finally, when we exited the function after changing the inner property of the friends dictionary, we printed out the ID and it was still the same. Now let's do something else. I'm going to print the ID of friends last seen, Rolf, before we call the function. And then we're going to print the ID of friends last seen, Rolf, after we call the function. Notice how friends last seen, Rolf will have changed from 31 to 0. Now, how many different numbers do you think we're going to see printed out in total? 1, 2, or 3? Hopefully you said 3. Friends last seen Rolf here is the number 31. Friend last seen Rolf here is the number 0. Integers are immutable, so whenever we change one, that is a new integer being created. Let's run it. And as you can see, we have now 3 dictionaries here. Three different numbers here. The first one is this friends last seen. The second one is this ID of Rolf, that's this one here. Then we print the ID of the friends dictionary, same one as the first one. Then we print the ID of the new Rolf number, and notice how 2 and 4 are different. And finally, we print the ID of the dictionary again, which is the same. So this is mutability in action. What we've seen is that the friends last seen dictionary has not changed itself, but one of the properties inside it has. Even though at no point we have modified the friends last seen dictionary, we've only modified the value that we passed to the function in there. Let me delete the IDs so I can explain things a bit better without all that gibberish. So again, what's happening is that these variables, friends last seen and friends, are just post-it notes on the value being this dictionary specifically with this ID that we got. When we pass the value here, what's happening is that we are passing the value of the variable. We're not passing the variable itself. So the dictionary now gets assigned to friends. Friends is just another post-it note on the dictionary. Indeed, we can print whether friends equal friends last seen. The equal is going to compare the contents. So if there were 2 distinct dictionaries with the same contents, this would return true. But is compares for the IDs. So it's going to tell us whether they are exactly the same object. And when we run it, we get true. Because this friends variable here that has the value of friends last seen is actually the same as the friends last seen variable that was defined up here. The same dictionary exactly. Therefore, when we mutate one, that is changing the Rolf property of this dictionary up here. Therefore, friends last seen Rolf will have the value 0 after we run the function. There we have it. So mutability can be quite dangerous, because if you change the dictionary in this function and then you're thinking, hey, yeah, we changed the dictionary, now we can use it. For example, say you wanted to use it here some more. You may not realize that it's actually changing everywhere else that you use that same dictionary. So it can be quite dangerous. Okay? That's the concept of mutability. However, if you go and have something like age is 20, and then a function that is increase age, and you do this, then you say ID of age, increase age, ID of age. What we're doing here is defining a variable that is a post-it on the value 20. Then we are getting the ID of that 20. We're calling increase age, which has the value 20, so current age is another post-it on 20. And now we're saying this post-it now points to 20 plus 1. So that's 21, an entirely different number. And then when we return, we print out the ID of age. What do you think we're going to see? Are we going to see the same number twice, or are we going to see two different numbers? Oh, we see nothing because we didn't print them out. Let's see if you guessed that one. Let's print it. We get the same number twice. What does that tell us on the value of age? What is age here? Age here is 20. What is age here? Well, it must be 20 because it's got the same ID, and we know that numbers are all different objects. So what's happened is that this current age variable has the number 20 assigned to it. But then what we've done is we said, now the current age variable is a post-it on 21, not on 20. Age is still a post-it on 20. So the number 20 has not changed. It is only the variables that have moved from one to another. Again, an important concept for mutability. If you do this on an immutable object, it'll just change within the function. This variable will now point somewhere else, but the outer elements will not change. Let's give you a third example. A list of prime numbers. The ID of primes will be something. We'll have to remember to print it this time though. Then we'll say primes plus equal 7 and 11. And then we'll print the ID of primes. What do we think we're going to see now? We get the same ID back. That is some bizarre functionality, right? This one is primes equal primes plus 7, 11. Surely it should be a different thing. We've moved the variable from pointing to this list, now points to the longer list. But remember, when I said that this is equivalent to this, I was lying. It is not. What's happening here is that the primes is equal to primes dot IAD. That. And it is up to the implementation of this function whether it's going to modify primes or whether it's going to create a new list that determines whether this is going to be the same object or a different one. Okay? And in this case, in case of the list, and in case of a lot of objects, when you do IAD, when you do plus equal or minus equal or times equal or divide equal, the Python official documentation says that when you do that, one of these iadd or isub or imul for multiply, they should modify the object if possible. So in the case of lists, iadd modifies the list. Okay. Of course, if you do primes equal 2, 3, 5 plus that, we're going to see two different numbers printed out here, because these are two things. What if we do primes equal primes plus that? We also get two entirely different objects printed out. Again, what's happening here is primes equal primes add 711. It is not iadd. Iadd is meant to, where possible, modify self. Add does not have that requirement. And in the case of lists, it has been implemented so that it creates a new list. So this is why this creates a new list entirely. Okay. So it's all up to the implementation whether the objects are mutable or not. So enough of this. Just remember, when you pass something to a function, that you can potentially mutate that thing, and then the value outside the function will have changed too. For example, with dictionaries, and you can do it with lists as well if you use plus equal, or indeed any other of the something functions. Unless the thing you pass to the function is immutable, in which case when you try to change it, it won't have changed outside the function, only inside. Essentially what you've done is you moved the variable from one place to another. Okay, that's it. I hope that this starts to make a little bit of sense. As you program more in Python, I think you'll be glad to have received this lecture from me in order to understand a bit more of what's going on behind the scenes with mutability and different variables. It really is a frequent question on a lot of online Python forums, questions, and Stack Overflow. So it's really good to know that this is how things are handled. So with that said, I'll see you on the next video.